Hey guys, today we're going to start our topic on exponents, and specifically today we're going to talk about the multiplication properties of exponents. If I were to giving you the power of a to the b power, the a is called our base, the b is the exponent, and the whole thing is called the power. Below I have an investigation for us to do. So in the first row here, I have 7 cubed, or 7 to the third power, times 7 squared, or 7 to the second power. If I were to write this as an expanded product, that 7 cubed would be 7 times 7 times 7, and then I'm multiplying that by 7 squared, or 7 times 7. Looking at my expanded product, I now have 5 factors of 7 there. So if I were to rewrite that as a new exponent, a new power, I would have 7 to the 5th power. Go ahead and try the next 2 rows, expand them, and then write the number of factors and what its new product looks like. Did you pause it? Please say you paused it. If you didn't pause it, I'm going to look stupid. Okay, the number of factors for 2 to the 4th times 2 to the 4th. You should have had 8. And your new power looks like 2 to the 8th power. X to the 4th times x to the 4th, again, 8. You'd have x to the 8th. What kind of pattern are you noticing with our product of these two powers and then what the product actually looks like? If you notice, for example, like 7 cubed times 7 squared, all we're doing is adding the exponents. We're just adding those exponents together. So the same thing down here, 4 plus 4, I got 8. 4 plus 4 also equals 8. Down here, we're raising a power to another power. So here I have the quantity 5 squared cubed. If I were to write that as an expanded product, I could say, well, this is the same thing as 5 squared times 5 squared times 5 squared, because that's being cubed. And then now that I have this new product, I can go ahead and expand that now. Same thing as 5 times 5 times 5 times 5 times 5 times 5. Now in this new expanded product, I see that I now have 6 factors of 5, and that can be rewritten as 5 to the 6th power. Just like I did in that example, go ahead and fill out the next 2 rows, please. Have fun writing b and -3 multiple times. I hope you paused it. This investigation would be really worthless if you didn't pause it and try it out. Okay. So the number of factors in this -3 squared would be 4. And our new power would look like -3 to the 4th power. For this b squared raised to the 4th power, there will be 8 b's, or you can write it as b to the 8th. What pattern are you noticing with our final product at the end and our power of a power? All we're doing is just multiplying the exponents together. So for example here, I have 2 times 3, and I got my 6. 2 times 2, and I got 4. 2 times 4, and I got 8. A small sidetrack. For this product right here, I had parentheses written around my -3. Are these two things here the same thing? if you want an answer, go ahead to your calculator, plug something like this in, plug something like that in. Do you get the same answer? We'll talk about it when we see each other in class next. So, taking our powers, writing them in words. When I have the product of a power property, to multiply powers with the same base, you're going to add the exponents. So for example, if I had a to the b times a to the c, that is the same thing as a to the b plus c. A huge thing here is they have to have the same base. So if I had a to the b plus c to the d plus, what are you doing? Times c to the d, I can't simplify that any further because they don't have the base here. For the power of a power property, to find a power of a power, you must multiply the exponents. So for example, if I had a to the b raised to the c power, that is the same thing as a to the bc. I'm just going to take the two exponents and multiply them together. Another property is the power of a product property. To find the power of a product, you must find the power of each factor and multiply. So for example, if I had the quantity a to the b, c to the d, raised to the e power, I'm multiplying these two powers together. This is the same thing as a to the be times c to the de. You can kind of think of it as we are distributing this e to both factors of this product. Below I have a couple examples. Just a couple. So you want to simplify and keep your answer as a power. So for this first one, for example, 5 cubed times 5 to the 6th, because I'm multiplying them together, I'm just going to go ahead and add their exponents. So I would have 5 to the 3 plus 6, or 5 to the 9th power. Jumping over to this one. Negative 2 raised to the 4th times negative 2. So I have the same base going on here. However, my second factor doesn't have an exponent. But it actually kind of does. So when there is no exponent to it, you can always put an imaginary 1 there. So really, this is negative 2 to the 4th times negative 2 to the 1st. So I'm still multiplying. I'm still going to go ahead and add my exponents together. This is the same thing as negative 2 to the 5th power. Jumping all the way down to here. I have 3 to the 5th squared. I'm raising a power to a power. So then my answer would be 3 to the 5 times 2. Or 3 to the 10th power. All right, I want you guys to try out the remaining problems on this worksheet, and then tomorrow I'll post the answers. If you have any questions, please let me know.